Hello ROS developers and welcome to the ROS Questions and Answers video series. If you want to learn anything about ROS, this is your channel. ROS navigation, ROS with drones, ROS for autonomous cars, everything about ROS is here. Learn ROS step by step and push your ROS learning in just 10 minutes of video. I am Alberto and today we are going to be checking a question I found in the ROS Answers forum, which is this one. And this user, Mark, he asks, how do I interact the real robot with visualization by RVs in MoveIt? So basically how to connect the real robot to MoveIt. And yeah, in the video of today I'm going to be reviewing this question, but before anything else, remember to visit our Robot Ignite Academy. Our online academy where you will find practical online ROS courses using simulated robots. No installation required. You will find a link to the academy on the video description. Now let's start with the video. So basically in this question, Mark is saying, so I have visualized my robot arm in RVs and the actual robot site also connects to Raspberry Pi with ROS installed already. I have read many documents and articles, but they made me dizzy. As what I have researched that I have to create a publisher in MoveIt, then send data to Action server. Is this I have to set up on Raspberry Pi? Then using ROS in Raspberry to control servo, is this plan correct? I am sorry if I make confusing, please help me to fix the problem for interacting with the actual robot. Okay, so we are going to try to answer this user and we are going to show an example of how to do this and what he will need to do. So yeah, for that let's go to RDS, as always, to the ROS Development Studio. So let's open RDS, and here I have created a project, which is this one, MoveIt Real. And what I'm going to do is to open this ROSject, which I have prepared with some packages. So let's open this ROSject. There we go. And let's wait a few moments until the whole environment, until the whole ROSject loads. And while this loads, I'm going to do one thing. I'm going to open the ROS Industrial course, for instance. So let's open this course in the Robot Ignite Academy, ROS Industrial 101. So I'm going to open this course here to wait for the ROS Development Studio to fully load. And here I'm going to be following some steps that are explained in this course in order to connect MoveIt to the actual robot. This unit, as you can see, is how to build a MoveIt package. I'm using here the Sia robot. As you can see, there we have it. And let me close all these. And here in the first part of the notebook, it's explained how to create a basic MoveIt package, which this is already done in my ROSject. So I will skip this part. If you don't know how to do this, you can check many tutorials in our YouTube channel. We have many tutorials about how to create a MoveIt package. So we are going to skip all this part and we are going to go basically to the last part of the notebook, which is moving the robot in the simulation, or what is the same, to move the actual robot, the real robot. Yeah? So how we connect the MoveIt package to the actual robot, which is what the user is asking. So we are going to skip directly to this part. Then, okay, so here we have our ROSject already loaded, so let's start. Let's open a shell first of all. Let's open an IDE as well in order to visualize our files. And I'm going to open directly a simulation. So I'm going to launch this Sia simulation. Let's open it here. Excellent. And as you can see in this ROSject, basically I have two things. One, in the simulation workspace, in this workspace here, the simulation workspace, I have my simulation of the Sia robot with the Sia control, Sia description and Sia gazebo packages. So this is basically all the packages for the simulation of the Sia robot. And then in my CAD-key workspace, I have a basic MoveIt package created here, which is called Sia MoveIt config. And a very, very basic MoveIt package, which is explained how to create it here in the first part of this notebook. And you can find many, many examples, many tutorials, many videos in our channel, for instance, about how to do it. So I'm not going to explain this. I want to focus on the connecting the MoveIt package to the actual robot. I want to focus this video on that. Yeah, so great. Here I have my simulation loaded. Oops, here we have the Sia robot. Excellent. Let's put it down here. So what I'm going to do now is let's launch our MoveIt config package. 1 second. There we are. So I'm going to need the graphical tools in order to visualize everything. I'm going to open them in a new window, better. Okay, there we are. Let's log in here. And here I will see the MoveIt screen. There we have it. Okay, I will need to move it a little bit. I'm going to use this command for that. There we are. So yeah, let's open here a new shell. Excellent. And here I'm going to execute the command I have just copied. There we are. And now I have my window correctly displayed. Great. So now, as you can see, I have here my MoveIt package of my robot, and I can plan here, if I want, I can plan some trajectories. So for instance, I don't know, let's do this one. I can plan a trajectory here, as you can see. It's planned in MoveIt, and I can even execute it. But this is not affecting at all my simulation, yes? So my actual robot, which is this one, which is represented by the simulation here, is not affected by what I am doing in MoveIt, yes? So what I will do now, what I want to do is to connect what I am doing here to my actual robot, yes? So this is what we are going to be focusing today. So great. Let's close our MoveIt package for now. We will reopen it later. So basically, let's start. So here, what I am going to do, the first thing I will need to do in order to connect the robot into the simulation is to create my controller's YALM file. Yes? So the first thing I'm going to do here is to create this file into the config folder. So let's create here a new file, which I'm going to call controllers.yalm. There we are. Excellent. And here I will paste this content. There we are. So basically, it's very simple. What I'm doing here is that I am connecting the controllers in MoveIt with the controllers of the actual robot. Yes, so how can I know this? If I do a ROS topic list here, let's do a ROS topic list. You can see that I have basically here all the topics related to the controllers and to the joints, which are basically this joint states topic, which will tell me the states of my joints at every moment. And then I have this joint trajectory controller. Yes, this is basically the main controller, which will be in charge of controlling the manipulator of my robot, the arm of my robot. And this is basically, as you can see here, this is an implementation of an action server. We have the cancel topic, feedback, goal, result, and the status. Yes. So this is basically an implementation of an action server. And this is mainly what you will need to have in your robot if you don't have it yet. Yes, and it's quite simple. So let's come again here to the IDE. Let's make this bigger. And here, if I come to the simulation workspace packages, I will have my, of course, I will have my URDF with all the joints defined and, well, with the description of my robot here in the description package. So if I open the, which is, I think it's this one, Sia10f URDF. Yeah. So if I open this package, you will see that I have here all the links for my joints, defined with the STL file for visualization. I have here all my joints defined. As you can see, the Revolut joints, joint S, joint L, etc. And at the bottom, I have all the transmissions for, it's down here. So here I have the robot cell, the table, the base, and okay, yeah, here I have the gazebo references with the materials and everything. And finally here I have my transmissions. And in this case I am using position joint interfaces. So there are many interfaces. I'm not going to explain this. We also have a course in our academy which is called ROS Control 101, I think, where all of this is explained with the transmissions, the controllers, etc. And then all of this is launched here in the control package. In the config folder, here is where I'm launching all my controllers, and as you can see, basically I'm using two. I have the joint state controller, which is of type joint state controller, and this one is the one in charge of publishing this joint states topic. And then the joint trajectory controller is the other one I have defined here in my control package. As you can see, here I have the joint trajectory controller. And this one basically is using all these joints, all the joints that are part of the arm, of the manipulator. And it's building an action server, yes, which is this action server, that is able to receive goals from MoveIt. Yes? So you will need to implement this if you don't have it, and a structure like this one, with the config folder, with your joint state controller, your trajectory controller, etc. Yes? You can find tutorials on how to do this. We even have a course, it's the ROS Control 101, it explains how to do this. And once you have this, you should have in your simulation, in your robot, in ROS, these topics, the joint states topics, and some topics for the action server of the joint trajectory controller. Yes? Then once you have this, it's very simple. So let's focus now on the MoveIt package. So yeah. Let's minimize this. Now, in the controllers file, as you can see, what I'm doing is I am connecting to this joint trajectory controller with the action namespace is follow joint trajectory, as you can see here. So this is the name, Sia10f joint trajectory controller. Yes, it's here. And this is the namespace, yes? Follow joint trajectory. So this is basically what I'm using here. I'm putting also the type that this action server uses, which is the follow join trajectory, and all the joins that will be controlled by this action server, yes, which are all of these: join test, join tel, join t, join to, etc. Yeah, then let's move on. So the next step will be to create our joint names file. Yeah, here it is explaining all what I have explained with the topic, why this topic, the type, etc. Then the next step will be to create this joint names YALM file. So this is what I'm going to do now, and I will copy the contents of this file as well. And this file is super simple, it's self-explanatory. So it's just a file with the names of the joins that we will be controlling. Yes? So basically of all the joins that we are going to be controlling, which are the same as this one, it's the same list. So we have this file with the names of the joins. Let's save this. Excellent, so let's move on. Then the next thing will be to populate this file. The MyRobot or whatever, MyRobot MoveIt controller manager launch XML. Yes? So we will have a file like this here. It's automatically created when you create a MoveIt package. Let's put this bigger. And it's this one. In my case, it's Sia10f MoveIt controller manager launch XML. And as you can see, originally it's empty. So we will need to populate it with something like this. So let's copy and paste the contents of this. Let's put it here. And basically what we are doing here is to load this controller's YARN file that we have just created. So as you can see, we will need to change here the name of the package, because in my case it's not my robot, it's Sia MoveIt config. So let's put here the Sia MoveIt config, controllers YARN. So yeah, that's done. And we have one last step, which is to create the planning execution launch file. The launch file that will actually launch everything and connect everything with my actual robot. So let's create this file. I'm going to call it Sia planning execution.launch. We will need to create it here in the launch file, so in the launch folder. So Sia planning execution.launch. There we are. So let's open this file and let's fill it. So I'm going to copy paste again the contents of this, and then I'm going to review it and to change what's necessary. Excellent. So first of all, I have here the package, the name of the package. I will need to change it. In my case, it's Sia. Yeah, it's Sia. So Sia MoveIt config. Here I'm loading the joint names YARN file. Then here again, it's Sia MoveIt config. Again here Sia MoveIt config. And one more time yet here, it's Sia MoveIt config. Then here there's a very important thing that we will need to take into account and to do, is here we need to remap the sources list to the joint states topic of our simulation. In this case this is correct, because I have it remapped to Sia10f joint states, which is currently the topic I am using. Sorry, I need to open again the simulation. There we are. And here I will need to remap this sources list parameter to the joint states topic that my actual robot is using. In my case, my actual robot, which is the simulated one, is using this Sia10f joint states, so that's why I'm remapping it to this one, as you can see here. Yes, so yeah, let's test this, let's see if it works correctly. I am going to close now the curse. I don't need it anymore, so let me close it. Okay, excellent. Then yeah, let's launch our MoveIt package again and see if it works. So ROS launch Sia MoveIt config, Sia planning execution, which is the new launch file we have just created. Okay, so we have again to move here the window. Let's do it here. There we are, excellent. And now, if I calculate a trajectory, it should move also the robot in the simulation. So it should also be applied to my actual robot. So let's try to plan a trajectory. Here, let's select a random valid state. Let's do a plan here, and let's execute it. And let's see what happens here. Oh, it failed the execution of this plan. Okay. Let's try another one. Maybe this one is too complicated. So let's plan again and let's execute it. And there it has executed it. As you can see, here the motion has been executed. Let's try a new one. This one, for instance, let's plan. Again, there we are, and let's execute it. Let's come here to see how the motion is applied to the actual robot, which is the simulated one in this case. So it is working. Yes? Excellent. So let's close everything, and this will be all for this video. Just in order to do a quick summary before ending. So basically what you will need to do is to create this controller's YAML file and the joints names YAML file in your MoveIt package. Yes, and in your controllers you will need to connect everything to the topics and namespaces of your trajectory controller action server. Yes, and this you will need to specify it in your packages, in your control packages of your ARM. Let's open it here. So as you can see, you will need to generate control for a control package for your manipulator, for your ARM, and specify two things at least. One is the joint state controller. You will need this in order to be able to track the states of your joints at every moment, and then the joint trajectory controller action server. Yes? You will need these two things at least. Yes? So probably this, if you don't have it, you will need to have it. If you already have it done, excellent. Then you just need to create all the MoveIt related packages, the controllers YAML file, the joint names, and then the MoveIt controller launch, which is this one that launches the controllers, and finally the planning execution file, which is the one launch file, which is this one, the last one we did, and which sets up and launches everything in order to communicate MoveIt with your actual robot. So, well, that's all. I hope you've liked the video, you have learned a little bit at least. And if you did like the video, please give us a thumbs up and remember to subscribe to our channel and press the bell for a new video every day. Either you liked the video or not, please share your thoughts and questions in the comments area. Goodbye and see you in the next video.